Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward.
Welcome to the latest edition of Happy Path Programming.
The holiday episode.
The holiday episode. It's December 24th.
And it's snowing cats and dogs here in Crested Butte.
It is.
Like many feet.
I think so.
Yeah. I did some snow blowing, and
As did I.
yeah, it was well over the top of my snow blower, so it was slow going.
It makes it hard. You have to kind of ram it into it.
Yeah,
right?
and back and forth.
Yeah. There's a lot of that.
Lots of digging my car out and just moving snow from one place to another.
But you have a new job.
I do. On Monday, I started as the Kotlin product manager at Google. So moving from Google Cloud over to the Android side of things. And we'll be doing Kotlin kind of generally. So trying to just continue to make Kotlin awesome for everything.
So, and Google is like a major contributor to the Kotlin project, right?
They are, yeah.
Okay.
Yeah, and I don't have a good grasp yet what all they have contributed. The one thing that I know is that they've been working hard on a new compiler, which is codenamed the K2 compiler. And it's, from what I know, I think, and I could be wrong about some of this, is that it's a total like rebuild of the compiler. And it is, do you remember this? I think all languages go through this cycle where they become successful, or if they become successful, then one of the first complaints that comes up is compiler speed. And usually what happens is that people get larger and larger code bases, and the compiler gets slower and slower and slower. And I remember when I was at TypeSafe, this was the big complaint about Scala. Like by far the biggest complaint about Scala was compiler speed. And so then the team invested, I would guess, person years into addressing the compiler speed things. And now in the Scala community, you don't really hear about people complaining about the compiler speed anymore.
It seems like part of that is when you're working within like IntelliJ is giving you feedback all
There's
the time.
a couple parts of it. Yeah. One is making that like dev loop, like your incremental compile, getting your red squigglies as fast as possible, like just that kind of inner dev loop. But then another one is when you just run a fresh compile on a project, you don't want it to take minutes. So there's kind of optimizing in both directions. One is just raw from scratch compile speed, and the other one is optimizing that inner dev loop incremental compile,
which is the most critical part to me.
Yeah. I mean, ideally you only do that like initial compile that could be long once a day, or very minimally, or your CI system is doing it, so it doesn't matter quite as much, I think, as that inner dev loop. So from what I understand, Google has been working on this new compiler in Kotlin, and it's allegedly faster. I think 1.6 was maybe where we first saw it, or maybe it's experimental. I'm still new in this job, so
I think 1.6 or something just is coming out now.
1.6 just came out, I don't know, a month ago, and then 1.6.10 just came out, and then there's even more improvements coming in 1.6.20.
So when we talked to Richard Feldman, we asked about this. So did you write rock in rock? And he goes, no, I wrote it in Rust.
Yeah.
And so what is the new Kotlin compiler written in? Do you know?
I don't know.
Don't know.
I'm guessing Kotlin, but
because I wonder, because I feel like Richard's, it always. I think it's a good test of a language to write its compiler in itself, but is it always the best choice? I kind of respect that, choosing to write it in Rust just for
and admitting that Rock is not the best language to write a compiler in. And instead of trying to shoehorn a compiler into a language that maybe isn't best suited for it,
and then maybe spending a lot of extra time doing performance tweaks.
Yeah.
And if it's like you start with a language like Rust, which is like, performance from day one, then maybe you never have to do that.
Yeah. Oh, and we should mention, we may have a special guest show up midway through this episode.
We'll see.
We'll see. Yeah.
We'll
but
see.
If not, we'll just do
Yeah.
our usual, or
Yeah.
not our usual. We haven't done it. Just you and
Wait a
I
minute.
chatting a while.
No,
But
it's catching.
it's just so fun to chat with other people. Not
Yeah,
that
it is.
I enjoy
No,
chatting with just you, but
no, you're right. Learn a ton of things.
yeah.
So what kinds of what kind of things? I guess I'm trying to figure out what your influence over Kotlin is now going to be.
Yeah, I don't know.
Yeah.
Still something to learn. I think in some ways I will be the Google person trying to make Kotlin more successful and better for developers. And obviously there are a lot of people at JetBrains doing that. And so back to your question about Google's involvement in Kotlin.
Right.
It was 3 years ago that JetBrains and Google created the Kotlin Foundation, and Kotlin is now under the Kotlin Foundation, and Google is one of the primary members along with JetBrains there, and now is making a lot of contributions to Kotlin itself. And,
right. So it's a foundation, so people don't worry about, say, like what happened to us with the Flexbook.
Yeah,
it's like
so
it's like an open source. It's out here. It's not controlled by a company. So don't.
Yeah, foundations put it into the Switzerland model of, all right, now we have a governance structure that allows different entities to have a way to steer the direction of things and a process to make decisions and all that. And actually that's one of the reasons why I think Flex died, was that there was a point when there were a number of companies that wanted to go big into Flex, and very large tech companies, and they asked Adobe to put Flex into a foundation, and Adobe said no. And then the company said, well, see you later.
Yes, well, yeah. No, I mean, with that experience made me go, if it's not open source,
well, and even beyond open source, so Adobe did end up open sourcing Flex,
but it was way too late. Yeah.
But just open source is not sufficient. So if you're one of these huge companies that wants to have a significant reliance on a technology, even if something's open source, that's insufficient for you to have comfort that you're going to be able to influence the direction and decision making.
Make sure bugs get fixed.
And so foundations are the way that has evolved as that Switzerland approach, where there is a formal process and governance model that dictates how different entities that potentially have differing needs, how those things get resolved. And that's Linux is in a foundation, Kubernetes is in a foundation, like so many of these foundational technologies that are
I'm really
used across
here.
competing
Is
technologies.
Java in a foundation? Because it seems like Oracle kind of controls it.
Java, that's a good question. I don't. I should. As Java champions,
we're
should know
both
this.
Java champions. We should know these things, but
I don't know how that all works with Java. I know that there is a governance model with OpenJDK that is, I would think, sufficient. So maybe not necessarily a foundation, but sufficient for many entities to participate in a worthwhile way.
Yeah. So, thank you.
Coffee delivery.
Yes.
So I should research more about the governance of Java. I guess there's a couple different structures. There's the JCP, so maybe that's kind of like the foundation,
the Java community process.
And there's there's a board, and so I think in a lot of ways that functions like a foundation with a governance structure that gives many members ability to influence decisions, and all that,
and doesn't give one company
all the
undue control. I mean, you get control by contributing. So Google's control is that it's willing to put
engineering resources.
Put engineering resources, but everybody
benefits
from that.
The reason to have the governance model is, let's say Google did want to make some huge compiler change or whatever to Kotlin. There's no if it's just open source, there's no way to kind of make sure that contribution will be accepted into mainline Kotlin, where now with the Kotlin Foundation and the governance model allows for there to be a decision-making process that likely if Google is going to spend a lot of time on a feature, that likely it'll be merged into
they can sort of go, this is a good idea up front. Right. That's interesting. That's because I guess you can spend a lot of time creating a pull request and not have it accepted, and I guess you can still use it yourself, but it's not quite the same.
So back to like compiler speed, I remember that when Java had major compile speed issues long ago, IBM developed EC4J, and all of us, everyone that was doing real Java, switched over to using EC4J, which was the compiler written, I'm pretty sure, for Eclipse to make Eclipse fast. But we were able to use it as just our normal compiler as well, and that really handled the speed issues. But that never was contributed back, as far as I know, back to the foundational Java project, and maybe Java wasn't even open source at that point. But then
I don't think
then Sun, I think, rewrote the compiler and made it faster.
Well, it lit a fire under Sun.
Yeah.
Because everybody was jumping ship, and they go, "Oh no, IBM might gain control." I think
maybe at the time, if there was a way for IBM to contribute that compiler to the actual project, then that
would have happened. But I think that was back when, people still didn't, they were afraid of open source, and they were seeing it as a playing ground to gain control over each other. The usual things. And Bill Gates said open source was a poison on, or whatever he said. Of course, Microsoft is all about open source. Man, they do a huge
Java,
amount.
doing a ton with Java now. Oh, I ran across a blog post from, I forget the date on it, 2008 maybe, by Mark Fleury. I was looking for an old Mark Fleury blog post about he called it like open source strip mining and waste dumping or something like that. But I'd also come across.
Do you assume all of our listeners know who Mark Fleury is?
Good question. He's the founder of JBoss.
Okay.
I've known Mark for a long time, and he always had some, in the day, like very controversial opinions, but now I think a lot of his opinions. So this was the interesting thing, is I came across his blog post where he was saying like the only way for Java to survive is for Sun to open source it. And
and you think this was in 2008?
I think 2008.
So that was at least 10 years of non-open source.
Right. And then now they, long ago it was open source, and I think he was very right that like Java, there's no way that Java would be where it is today.
Which programming language do you want to use anymore that isn't open source, doesn't have undue control by one company?
Yeah, exactly.
I mean, it's like that's just.
I think Java would have died out.
Oh yeah. I mean, it's just like baseline. I wouldn't use a programming language that wasn't that way, because you don't know what's going to happen.
So I saw, kind of related to programming languages, the Advent of Code thing.
Yes.
It runs like all of December, and there's these coding challenges.
Right.
And I've never done it.
I've heard of it. I've never looked into it.
So they do a survey of the participants, and by far the most used programming language was Python. And then I think it was JavaScript after that.
Makes sense.
And then I forget the total order, and anyone can look up the survey. It's interested, but Rust was actually very high on the list. I found that pretty interesting.
If you're like, who shows up to these things? People who are interested in playing with new technologies. New things, Rust continues to gain interest, and people keep saying good things about it. Every once in a while you hear, oh, it's maybe not polished in this area or that area, but from what as somebody who uses Python, the struggles that I've had trying to create Python extensions, I don't know if I've ever successfully created one. It's so complex, and this Rust 02 system for creating these seamless modules. Most of the time you're going to do extensions for speed.
Yeah.
I was like, well, use the fastest thing out there, et cetera, et cetera.
Yeah,
like,
Rust just makes a ton of sense.
I wouldn't want, I mean, for me, doing a big project in Rust, it's like that. Oh, that doesn't appeal to me. I think I do want all the things like garbage collectors and you know, all the stuff that gives you.
Yeah.
But for a fairly compact thing to solve a particular problem, I would, and the Rust book, you know, what I've read of it is just
reviews,
so well written.
Yeah.
And that's just part of the standard distribution.
Yeah.
So what a great way for people to get started.
Yeah.
No, I mean,
they've done a lot of things really well, for sure.
It's interesting how many...
Cargo gets rave reviews.
Sure. Yeah.
Build tool.
Yeah. I mean, right. A nice build tool. What a concept. Yeah. It's, I don't know. It's very interesting to see how many people have tried to solve the problem of C. You know, C, it's like that one language that we encountered. Maybe we'll interview the guy who created it, where he goes, oh, I'm not gonna replace C. I'm gonna fix it. I'm gonna fix the preprocessor so it's not different bad language. I'm gonna, you know, do a bunch of things, but it's like actually a better C, which was what C++ was originally supposed to be. And it's like, and then, you know, Go is a replacement for C. You know, there's all these different languages that are a replacement for C.
Yeah.
And it does seem like Rust might be, you know, if you're going to be at that level.
Yeah. Paul Cisano, one of the creators of
the Red Book,
Unison, and the Red Book, the Red Scholar book, he had a series of tweets yesterday, I think, about Rust, and he was like Rust is at this point the total obvious choice for systems programming. And he's like, outside of systems programming, you should really be using a garbage collector. Like you should not be. A human garbage collector is just a waste of energy unless you're doing systems programming.
Yeah. I mean, that's one of the first things I encountered when I tried doing any like serious C work with somebody's library is like, oh, by the way, you're the garbage collector.
Yeah.
It's like, I didn't even know. I think,
And I'm sure Rust is a much better option for. It makes being a human garbage collector a lot better than C and C++, but still, it's a human garbage collector.
Yeah, it's extras. I mean, it's all the stuff we're trying to get away from with functional programming. All this rote work.
Yeah,
it's like, no, we're gonna turn that inside out, and you're gonna take all of these mechanisms, and you're gonna adapt them. Typically using like just a lambda. You're gonna go, oh, here's the code that makes my program different, and all the rest of the stuff is in your foundation. And it's like being garbage collector makes total sense for the kinds of things that you would write Rust for.
So JetBrains announced Fleet a couple weeks ago. It's their new lightweight IDE.
Have you looked at it?
I haven't tried it. Yeah, I think it's in private beta, and they maxed out. Like they had so much interest instant. Yeah. And so they did reveal that I think the majority of the code for Fleet is actually written in Kotlin, and some portions are written in Rust. And I was like, this is interesting combination for writing something that is, needs some serious performance, but also you're writing a lot of UI, high level stuff,
native connection stuff. Yeah. So you can see that's broad. And I'd be interested to see, what is the foreign function call interface, or if that's how they're doing it, or, how would they architect that so that, where's your Rust and how do you talk to it? And how does it interact with, this was one of the...
the interop piece.
The interop piece,
interfaces or whatever.
In Python, the biggest problem with writing modules, in C or whatever, is that, C doesn't know anything about garbage collecting or anything. And basically, Python's got this garbage collector. And I was like, how do you interact with that? And that's where you have the global interpreter lock to say, okay, we'll just, when you're calling this C function, we'll just, freeze everything.
in
the Python program. So, and then it gets all tricky and
interesting.
confusing.
Yeah, it'd be interesting to know how with Fleet how they handled the memory management.
And so is it mostly, I mean, gosh, what's it going to look like? Is it going to look like IntelliJ but way faster?
I don't know.
Yeah, of course.
My guess is that they're really trying to have a answer to VS Code.
Yeah.
And so I'm guessing that it's going to be more along those lines.
Because I find myself going back and forth between
VS Code and
IntelliJ and VS Code. And it's like IntelliJ does these things good, and then there's some, like, I don't know, for some reason, I'm sure the functionality must be there to do some of these things, but it's just easier in VS Code to do, basic searching and replaces, renaming and stuff like that. So I often I'm basically using VS Code where I used to use Sublime Text or Ultra Edit or all the, basic text editors that I had before.
And then there's some other feature of Fleet, which is remote development, like, because I think the idea that I don't want to be working on my local machine for a variety of reasons, like the GitHub code, whatever it's called. There's been this like flurry of moving your development environment to the cloud, and so I think that Fleet also has like a cloud development model to it, which I don't know. I need to dive in and learn more about this, but
I'm concerned about that trend, especially since Amazon's been just going down weekly for the last several weeks. It's like, what if we get too dependent on the cloud? I mean, it's like, I want to be able to just immediately drop back to local. If they had that, and they probably thought of that.
Yeah, I really like using my machine for development, and there are a lot of ways that we can make that experience better. I talked about that so last week I did a webinar kind of thing. I don't know if that's the right way to call it, with test containers. Remember, so last week we had Sergey on, and then it was the day before. The day before that,
you and he had done the webinar.
Yeah. And so we talked in that. It's up on YouTube on the Test Containers Live or something channel. But I talked a lot about why development I think is moving to the cloud, and I think that we're moving the wrong pieces to the cloud. We should be moving our service dependencies to the cloud, which is what Test Containers is doing. But because of the pain of installing development tool chains, like Ruby is so freaking hard and horrible, I think that's a big reason why you see this like move. It's like, it's too hard to set up my development chain on my laptop, so let's just move it to the cloud and let somebody else deal with it.
That reminds me.
It's like, or we could just make it better to install our development work, tool chains.
That sounds too hard. That reminds me, this was a conference, I don't know how many years ago. It might have been, the Code Mash. You remember Code Mash that Diane and anyway, I think they had like a morning Ruby or Rails tutorial or whatever, and I went to it, and I had a Windows laptop.
Oh yeah,
and they were like, I mean, you could see the blood drain out of their faces. They're going, oh, we don't have. I mean, you sort of have to have a Mac to do Rails development. I'm going, wow, platform dependency for your development environment. That's interesting.
Yeah.
No, and I think they also engaged me to help anybody else who showed up with a Windows. I've had that happen before. It's like people, I don't know.
For a long time, Node just didn't work on Windows at all. They were just like, we don't support Windows.
It's only how many? What's the number of Windows machines out there versus the number of Macs?
You see every developer study, and Windows is by far the most used developer
platform.
Oh yeah, absolutely. Okay. Like even just the Advent of Code one showed Windows like off the charts, like so much more used. Than
this
else.
Just I feel like I'm being stubborn by using Windows, but I'm going because there's a lot of people out there who use it, and this reinforces that. It's like, I mean, I want it to work. I want everything to work on all platforms, but that means somebody's got to be doing everything on Windows, and I'm fine doing that.
Yeah, you'll be the one. Yeah, I mean, it'll be interesting. I think WSL is gonna. Yeah, so the solution is just to run Linux on your Windows, and then
It works really well.
it does.
Yeah,
There are some issues that I've had with it, but
sure, but it
generally
keeps
it's
getting
pretty
better. I
amazing.
mean,
It
the
keeps getting
WSL.
better.
I've never tried. Have you tried any of the UI ones in
Yeah.
WSL too?
So most of the stuff that I do now for demos and all that, I use Windows and WSL, but then I run IntelliJ in WSL, and through WSLG it renders IntelliJ as a native application. I don't know how magically how WSLG actually does that, but there's a few issues, but it works a lot better doing it that way than the other way is to run IntelliJ in Windows and then have it use the shared file system. And there's just like endless issues that come up through that way of doing things. And so it's like, but neither are perfect yet, but for all of my like normal development, I'm on Linux, and then I don't have to worry about any of these things. But for Windows stuff, like the WSLG is pretty impressive. WSL is basically just full on Linux at this point and I've had very very few issues with the actual like Linux piece of WSL. It's just the WSLG is a little.
And how unbelievable is it that that's just part of Windows now?
Yeah. For anybody that doesn't want to try this, it does require Windows 11, the WSLG part.
Oh, I see. Okay, yeah. I checked when they first started announcing it, and at least the machines that I had said, "Well, it's not ready yet," or something like that. So I haven't looked again.
Yeah, I did the upgrade. Easy. Worked fine.
So back to your job.
Yeah.
What kind of things are you hoping to do with Kotlin, and what kind of things are you hoping to do basically?
Yeah.
In this world,
I think maybe the big picture is just make Kotlin more awesome for developers. I mean, it already is awesome, but making it even more awesome. And I don't know what exactly that looks like yet. The place where I have been really interested personally in Kotlin is in the idea of being able to use Kotlin for almost everything. And so I've done a lot of experiments. This is what they call it, Kotlin multi-platform, around the ability to take Kotlin code and share it across a server, an Android app, an iOS app, a web app, a desktop app, a CLI app, like being able to use Kotlin everywhere. And
you mean are we talking single source for all of these things?
Almost single source.
Okay.
Almost single source. This is where personally I'm just like, oh, there's a lot of potential here and a lot of interesting things. So a little more detail on that. I've been working on a sample application that does exactly all these things, and the UI is. I'm doing the UI through Compose, which is initially created as the Android UI toolkit on top of Kotlin. But JetBrains has taken Compose and made it work for desktop applications and web applications and iOS applications through Kotlin multi-platform.
Okay.
And this is what they call KMM, Kotlin multi-platform mobile. I don't know. Anyways, so the idea of like sharing your UI code. The one caveat to this is that I don't know, and this is something I'm sure I'll learn about as I dive in further, but the way it is today is that the Compose Web is a different API than Compose for desktop and mobile. So desktop and mobile have the same API, but web has a different one. And I'm guessing that the reason for that is that the browser is just too constrained to be able to really take those desktop and mobile UIs and 100% port them over. Maybe I'm wrong about that. Maybe they're working on it. But the way it is today, it is too different. It's the same Compose programming model, but different libraries that you use between web and then the others. So
you would have to write different code for that.
For those two. Yeah.
Okay.
Yeah. And maybe there's some amount of sharing you can do. I haven't dove too far into it yet, but at least it's Kotlin and it's the same UI programming model in the all those places, and so So it'd be interesting to see how that all plays out. But but so far been a pretty delightful experience being able to build UIs for all those different platforms as easily as.
And Compose, didn't they just release it last summer or something?
I think 1.0 came out in the last few months or something.
Okay.
Maybe last summer.
So this is still pretty fresh.
Oh yeah. And then it's been the JetBrains effort on top of that to take Compose beyond just Android. And so yeah, it's, I think it's still pretty early days on this front, but there's a lot of potential, and I have no idea if I'll be working on this at all. But so that's kind of like I think the interesting, very kind of unknown how that's going to play out. But what a lot of people are doing already is just sharing data classes and business logic across all the different platforms, and that's pretty solid today, and people are doing that reliably, and across web, desktop, or web and all the different mobile platforms primarily. So
well, being able to do that's pretty huge already. It does seem like not having to switch languages or even maybe having a front end person and a back end person. It's like, how many smaller places you don't get to have a dedicated.
You've got more full stack people. But then there's a lot of logic that you want to have on both sides, and so being able to share those logic pieces very in a trivial way and have it work reliably is a huge gain for a lot of people.
Okay. And is there anything else?
I just don't even know yet. It's just diving in, and with the holiday season, just getting
a few days
oriented. But it's going to be fun to see how that'll all play out. And I'm excited, and I'll still be doing some Scala stuff, and working on our book and all that. I still think Scala is awesome, but Kotlin just seems like today it's a much better option for the masses. I love the effect systems and pure functional programming, and going crazy with all the Scala stuff, but there's definitely a huge learning curve too.
And the other thing is, yes, there's a learning curve, but I find when I study a more, I don't know, call it a more advanced, more sophisticated language system, etc., when I go back to, what other language I might be using on a day-to-day basis, it changes the way I program. And I think that, is going to be, and is there anything you're going to miss about Java?
I mean, I haven't really written much Java in a long time, so
yeah. Good answer.
Yeah.
It's like not having to deal with that stuff. It's like, and now, I mean, I feel for all the people who are still trapped in Java world for whatever
people
reason.
Are very happily there.
Some people are happy there, and they can be functional, and they can do things that solve their problems, and that's great. But I'm always kind of looking to climb up to what is the next level of not just productivity, because I used to say productivity, but since we started working on our book, I realized no, I can write broken programs really fast with some high productivity language that doesn't think about reliability. But it's like it's productivity without reliability is just noise.
How can you have both?
And so, like, there's a lot. I think all that wheel spinning, just chasing down null pointer exceptions. It's like how much it's like companies are wasting vast amounts of money on that, and they're losing money by not having the whole deal. It's like, okay, it really is
production
important.
Issues and
we want to. It's very important to move forward because we still aren't. There's so many things that you look at and you go, wow, there should be a piece of software to solve this problem. And it's like, we're bogged down, I think, by the unreliability of the code that we write.
Yeah.
Among other things.
Yeah.
And, how.
Yeah, and so it's. I like that you bring up null because that's called the $1 billion mistake or whatever.
A lot more than that.
Yeah, probably a lot more than that. Yeah. But I think that mutability, like default mutability, is actually the $1 trillion mistake. And that's one of the things that I love about Kotlin is that immutability is much more natural, much more default in Kotlin than in Java.
They look at it in like the libraries that they create. It's present, and I feel like in Java it's just like, no, everything's a variable. Why would you think otherwise? We're just going to treat it that way. Everything's mutable. There's a few things like they have the wrappers around the collections where if you try and mutate it, it throws an exception at runtime. Not much you can do with that. But in Kotlin, they're actually trying to create libraries that are immutable based, so that you get the other benefits from that. So it's like, that both those two things. And even if you don't understand all the ins and outs of functional programming, the benefits that you get by making things immutable is like
so huge.
It is. It's huge. So it's like, okay, let's take that step one. And
I think that one of the last times I wrote Java, I was sharing a date formatter or something across a multi-threaded program. And it turns out that
was a bad idea.
That was a bad idea because date formatter is like not thread safe, and so you just get unexpected behavior. Like things just don't work like you would expect them to. And how is it conveyed to me, the developer, that I should not use a shared date formatter across the multi-threaded server application where multiple requests are coming in? I should just know that, right?
When I first started encountering that, people would go, "Oh, that's not a thread safe library." And I'm going, "Oh, shouldn't there be a decorator or something, or some big blink tag going not thread safe? Don't be careful when you use
the idea
this.
That you can create a not thread safe anything is wrong. Everything should be thread safe,
right? So it's not something that because a beginner programmer grabs this thing and starts using it in a context.
Even a very experienced programmer like myself grabs this thing and uses it in a way that is producing totally unexpected behavior.
It seemed like it was really straightforward to use. Why would I have suspected that this wasn't that way? Oh my gosh. And then all of the the thing that got me, I have this problem when people present one way and then do something else. And so Java, we're smart people. We design Java. Everything's great. We even have a thread system and everything. And then decades later, you know what? We really need to deprecate all of those thread methods there because that was a complete, those never worked. But all this time they were telling us we're awesome. No, this is a personal problem for me. Is that if you present one way and then there's this other thing which is really different.
Maybe we should, the at deprecated or whatever annotation.
Yes.
Well, we should rename that to I'm sorry.
Yes. I apologize. At apology.
And then you have to write out your apology in the annotation.
Yeah. I'm sorry. I didn't know what I was doing.
We all certainly
make mistakes all the time.
And
I have tons of mistakes.
Need to correct for the mistakes we've made.
But I think acknowledging up front that this might not be the most awesome thing, rather than saying the opposite.
Threading's just freaking hard.
I've been studying various kinds of concurrency. Literally, I remember the first time I was introduced to it. It was an assembly language class when I was in graduate school, and I was going, doing two things at once. My brain is feeling constrained by this concept.
Yeah.
And that was on, a very low level. And then it's like trying to figure it out I think this is a more extreme case, or at least another version of the curse of the monad.
Yeah.
It's like, you get concurrency and you can make it work, and it seems obvious to you, and you're totally unable to explain it to somebody else.
Yeah.
Yeah. So all the different explanations that I've seen. And I mean, that's, one of the things that Zio does is manage concurrency for you. So that you're not
and Kotlin coroutines are a nice,
Kotlin coroutines,
I would say the easy concurrency model. Which
we didn't put in the book. We started looking at it, but it just seemed like a bridge too far. So at some point, and I still haven't looked into Kotlin concurrency.
It's good. It's I mean, it's not as full blown powerful as like Zio or something, but it's a nice simple API. And
I mean, ideally you want something that doesn't get you into trouble, like believing in locks and threads with Java, where it's like, because when I was doing experiments when I was writing Thinking in Java and have the concurrency chapter, I was doing experiments and it's like every time, I'd get these things going and they kept deadlocking, and I'm going, what am I doing wrong? And and that annoys me too. It's like I was blaming myself, and then many years later you discover, it never worked. It was just
hard for everyone.
It wasn't hard. It was broken. It was broken at a fundamental level. And so it's like,
Yeah, I think, like you, one of the reasons I like Kotlin is that it makes the easy path and the right path closer together than other options.
But they still have builders.
Yeah, I'm definitely not a fan of the Kotlin builders, but they're not. It gives you a nice DSL syntax, but as you know, I really don't like the mutability.
Well, yes, and originally in the book, I had a complex, I don't know what it was, a 2 or 3 dimensional structure, and I wanted to initialize it, but in an immutable way. And I couldn't figure out how to do it, but Svetlana showed me how to do it. But it's like kind of mind twisting.
Got to turn your brain around.
And then later she said, we should take that out and use builders instead, because it's so hard to get your mind around. I mean, it's another one of those kind of functional programming things where you go, okay, I see the benefit of this, but it's hard to twist my mind around so that I can do this naturally. And so I understand the reason, because if you look at a builder, it's pretty straightforward to
a Kotlin builder. And that's the Lambda with receiver pattern, or what's that called?
Which is it's what they called it. And then when I finally figured it out, I said, oh, that's an extension Lambda is what that is. And that's how it's like a little DSL. And so that's how they implement it. But and it's, I mean, when I was reading Runar and Paul's book, and I came across this thing where they're going, well, the important thing is not, you can have mutability under the covers as long as it's never visible. And so that kind of shifted my perspective on like what is immutability, and even the builders. But the real question is it invisible?
Right.
What they were talking about was invisible.
And I'd say that it's not invisible.
No.
So an example of this from Kotlin DSLs that I see is, so let's say you've got a DSL where you've got a list of options, and in your DSL you allow the user to say option foo, option bar, right? So they're calling an option method in the Lambda with receiver, the Lambda extension method. You as the developer have no idea. It's not conveyed to you through that API. If I call option twice, is it adding each of those? to the list? Is there even a backing list that's mutating when I call each of these? Or is it overriding option? Maybe I can only have one option, and by specifying calling that method more than once, I'm actually just overriding it sequentially or something. So the mutability is actually leaking through, so that then the user needs to know by looking at essentially the API, what is this thing actually doing? And I've had to look into the source code for a lot of builders to be like, what is actually happening here? Is this mutating this thing? How is it mutating it? Is it adding it to a list? Like, how is the list initialized? What are the defaults of the list? Like, so it's one of those places where I think that mutability leaks through and creates, I think, a poor experience, because it then makes me have to learn what the internals of it are.
The builder pattern is we're creating an object in multiple steps. That's the key. And so that, and I guess if you look at it from, okay, if the atomicity of the creation process is nothing, there are no side effects. Creating an object is kind of a side effect, isn't it? Anyway, there's no side effects until I call, give me the object. Yeah. If that's your sense of atomicity, then it's like, oh, okay, there's the builder. I do things to it. Nothing really happens until I call, give me the object. And then it's like, okay, the constructor's complete. Yeah. But because those steps are in there, it seems like I'd say the leaking is probably from, oh, okay, I'll create an object and put it in there. And, if I get partway through and the thing fails, then what happened because I was creating these intermediate things and putting them in there? And it's like, it depends on what the programmer's doing, I guess.
Right. Yeah.
So, it does seem like it doesn't have to leak out, maybe, but it can.
Yeah, but it can.
Yeah, if you're using it, you're going, okay, I got to think about what happens if this thing fails partway through.
Yeah.
If you're conscious of that, then you're more likely to not have any impact if the builder fails.
Yeah.
But
I guess,
no guarantee of it.
With behavior, what I really don't want is the answer for any question I have to be, it depends. And with mutable builders, almost always I can come up with a question that the answer is, it depends.
Mm-hmm.
And I don't want there to be any it depends answers. I want there to be types that convey exactly what valid states are and constructors, immutable constructors, to create those types. And
I guess that's the whole, the foundational answer in concurrency is it depends. It's like, well, what strategy should I use to implement my concurrence? Well, it depends.
Yeah.
And it's like, that's kind of it.
Yeah.
And
how do I do X concurrently or whatever? The answer is,
it depends on what your needs are. Yeah. And it's like, what you've done is you've just dropped a whole bunch of homework in my lap. If I'm using a builder, I'm going, oh, I can create an object. Well, it depends. Oh, now I need to go and dig in and figure out how this builder is actually working. It is no longer this transparent utility that I can just not worry about. It just does work for me. And now it's making me do work for it.
Yeah.
I don't like that.
Yeah, and I think maybe the defense of builders is that sometimes APIs, it's really hard to model the valid states in a mutable typed way.
Mm-hmm.
And probably a lot of times around protocols. Like, you think about trying to do this around the HTTP specification. There's so many places where the protocol itself in HTTP, the answer is it depends. And so if you're building something on top of a protocol where the answer is it depends, then probably you're gonna have to, at some point, the usage of your API around that protocol is the answer to a question is going to be, well, it depends, because the underlying protocol, it depends. So.
Yeah, just just saying that, like, all of a sudden you're steaming along doing work, and then somebody says it depends, and then suddenly it opens up to all these different possibilities that you have to figure out.
Yeah.
Or you have to
and that you can't validate at compile time, which is one of the reasons why I hate the it depends answer, is because whenever the answer is it depends, you can't validate it at compile time.
And I think we ran into a little of that like in the last couple of days when we were looking at resource cleanup.
Yeah.
And the trickiness to that. Part of the problem I think with that is that a lot of the time you don't have to worry about resource cleanup. Garbage collector takes care of it, or thing is.
Yeah.
But then so that means when you do, you have to go, okay, I've got to try finally, try catch finally thing here. But then in the finally, if I close this other thing, it could throw an exception. And how many catches do I have to do before I know that I've caught everything in it? Is that
then you've got like dependent resources and managing the closing in the right order and all the different places where exceptions can get thrown, and the handling, all right, this one threw an exception, but I still need to close the outer one.
And you don't know if you've done it right until the error happens. And the error mostly doesn't happen. And so it's like you've got code in there that is broken, but you don't know because you go, oh, this order seems correct and nothing goes wrong. So on you go.
And a lot of times it's hard to write tests for that kind of stuff too.
Yeah, because you have to generate the failure, all the different possible failures, and then and like, what if maybe the order doesn't matter that much in many cases?
Yeah.
So you get used to thinking, oh yeah, I'm doing the order right, and then you come across something where it does. It's like, oh, what's happening?
Definitely a place where it's just way too easy to do the wrong thing.
Mm-hmm. Yeah. You really want the library creator to be the one that decides how cleanup works.
Yeah.
So that you don't have to think about it.
Yeah.
And I think that was really the idea of destructors in C++. I mean, they have what was it called in Java? The equivalent of the...
No one really uses them, right?
Well, it's deprecated.
Oh, it's deprecated.
Again, 20 years later, they go, oh, oops, this actually doesn't work. We got to deprecate it.
Huh.
Yeah, and it's probably... I don't remember what the discovery was, but it was like so bad that they had to deprecate the...
wow.
Whatever it was. Yeah, exactly. Wow. I mean... how many of these things have to happen? Yeah. Well, and then there's the thing that Brian Getz talked about in this video that I saw sometime in the last year, where he's going, oh, the serialization and deserialization, we really need to do something about that because it's a security hole.
Yeah. And we had some debate about that on Twitter after our talk we did.
Whether it was a security... Well, Brian Getz said it was a security hole, so I'm going to believe him.
Security issue there.
Well, I think it was that you could inject code in the... and then hand it to the other thing to be deserialized. And you could run whatever code you wanted.
Yeah, there was some issue there.
Mm-hmm.
Not quite as bad as the log4j issue, but...
Well, I think it could be worse, but it's like log4j is just, here's an interpreter just right out here in the open, and throw us your code and we'll run it.
Any input we log is vulnerable. Yeah,
we solved a problem for somebody by doing that. And created a huge number of problems for everybody else.
A little foreshadowing to next week, we're going to dive into log4j and log4shell and some of the open source things around that with a special guest. So that'll be fun.
Nice.
Yeah.
Well, that should be very interesting.
Yeah. So I'm super excited about the job and have no idea what it entails, what I'm going to work on. Where it's all going to go. But I guess as a product manager, I'm supposed to listen to people. So if any of our listeners have have requests for what they want to see in Kotlin and where they want to see Kotlin
how about
go.
a ternary operator? Why are you laughing?
That came up on Twitter. And
twice. I saw two people going, I really need the ternary.
Really need the ternary operator.
Why? Why do you need the ternary operator?
I'm not gonna totally shut down that request yet, because maybe there's information I don't have.
That's right.
But my initial reaction is that what I've always appreciated from the ternary operator is that it's an expression.
Sure.
But it turns out that Kotlin's if then is an expression as well. So
almost everything's an expression in Kotlin.
So I haven't found the need for a ternary operator in Kotlin.
Well,
but I'd like to hear more about why people need it.
If you can figure out what need it satisfies, and if it's just brevity, then I think I've never been able to easily read. I mean, C has had ternary operators, so I've been exposed to them forever. But every time I come across one, it's like, okay, stop, think about this. What is this actually doing?
Right.
And then, whereas an if expression
gives you some cognitive overhead that you got to
right, and you can do everything with an if expression. Can you even have curly braces with a ternary operator? I don't remember. In other words, a ternary operator is usually for really brief.
Yeah,
it's kind of like,
I'm guessing in Kotlin you could throw braces in there, but
in Kotlin you could, but in Java,
in Java,
I don't know.
With a ternary, I don't think so. But
I don't know.
Maybe I'm wrong about that.
Yeah, I mean, no, it's like we don't know it because you wouldn't think of doing it,
right?
And then how do you? Well, because how would you return values from that?
Maybe you could toss a lambda in there. I don't know
at this point, but whatever.
Make everything an expression.
Yeah, well, and if can do everything that a ternary expression can do, then, and it's clearer, I argue, then why would you need a ternary expression? It's just going to make your code less.
I'm not going to shut down the idea immediately, because I would like to hear more, but my initial reaction is that I haven't personally needed a ternary operator in Kotlin.
Don't know that. Yeah, I'd have to say what pain point is it solving? Yeah. So, but other than that,
and sometimes the pain point is familiarity. Like maybe people are really accustomed to using ternary operators in Java, and so.
But then we get while loops.
Yeah,
it's like that's probably one thing I would say. Kotlin could have left out the while loop, and nobody would have missed it.
Yeah,
because you can do that with.
It's always a hard thing, I think, to find the balance between how much do we try to move you out of potentially broken paradigms into something new, and how much do we give you something you're familiar with.
Mm-hmm.
And I think it's a balance. There's never probably 100%, in one way or another. There's trade-offs in both directions, and so.
I guess so, but if it's something where it's duplicated functionality, that to me, it's like, okay, that's just cognitive overhead. Because it's like, now when I'm reading code, I have to go, here's a for, here's a while. I see it's doing the same thing as a for, but it's just a different.
This is one of the reasons why I think Scala is not necessarily the awesomest for the masses, is that there's just generally too many ways to do things.
It is. There were all these experiments.
Right.
And
this legacy of PhD postdoc experiments in a language.
Right. And it's like, well, let's try them and see what works and what doesn't. Well, we now know a lot of things are maybe counterproductive, and it would have been nicer to. But in Scala 3, they
did
added a whole bunch of other cool stuff. I mean,
Scala 3, I think, is a lot better chance for larger adoption than Scala 2, just because they've taken a lot of those. Here's 10 different ways to do this thing and reduced it down to 3.
Yeah, because if I'm reading code and somebody's using one of the other 10 different ways, I have to figure that out. And that is unfortunate, because you really do. It's needless confusion.
Yeah.
But now we know that, and some of the improvements in syntax in Scala 3 is just. It's like, finally, I'm much more comfortable with it than than what we had before.
Speaking of while loops, I don't think I've written one in a really long time. And
I've written them to demonstrate what a while loop is. That's it. It's like oh man, have I ever written one because I go, oh yeah, I could use a while loop here. I don't know. It's just, well, and also my awareness that, okay, and then the reader of this code is going to have to go, oh, a while loop. I wonder why they used a while loop. Oh, okay, they could have used a for loop, but they just used a while loop here.
Or recursion.
Or I guess.
Recursion is definitely hard for my brain to grok a lot of times, but I do find that I have an easier time grokking recursion than I do a while loop.
Yeah. Well, and I think for me, the big jump with recursion was, and I don't know if we've talked about this on the podcast before, but I always find recursion confusing when they introduce it like in an early part of a language, because I'm going, wow.
Yeah, I mean, the number of times I've had to write something recursive in the last decade is so few.
Right. And so you're going, why are you teaching me recursion? And then when you understand that, oh, it's because map and fold and
we have all these higher level abstractions.
These are
now.
Implemented recursively.
It's a foundational thing, but it's hopefully something low level enough that most people don't have to actually.
So they're immutable, and they're all those things. So you get these rock solid pieces. So you don't ever actually write recursive code yourself. You simply use it, and you can say, oh, and that's why we've taken the for loop and we've turned it inside out and turned it into, a map or a flat map or, all those different things. Oh, okay, that makes sense. Yeah. Now I understand. You wanted to show me recursion so you could show me how you could do this loop immutably. Yeah. And it's like, now that I know that, I don't have to write that code myself. Okay, it all makes sense now. But
it's like, do you first teach the recursion and then the fold, or the fold then the recursion?
I would say the second way, because if you teach recursion, I mean, my impression was, oh, so I guess I have to use recursion everywhere.
Right. Yeah.
And the answer is yes, but you don't have to write it. And that part I didn't get.
Yeah.
And so it's like, no, it scares a lot of people off. They go, oh, functional programming. Yeah, that means you're writing recursion everywhere, and you're going to be stuck. Every time you need to do any kind of loop, you're going to have to go, okay, recursion. How does that work again? Yeah. It's so well, and it's the same kind of thing with monoids and monads and things like that. And it's like, well, what you want to do is be able to assemble these, compose these things together and know that it works okay. And you go, wow, that sounds like magic. Well, let me show you the magic. It's monoids and monads and stuff. Yeah. And you go, oh, and if you introduce those too early, then it's like, oh, wow, do I have to be thinking in math space all the time?
Right.
The answer is no. But you don't know that.
Yeah.
The way that a lot of this is
start with the for comprehension and then unravel to the monad.
Yeah. Well, that's what we're trying to do in the book. Yeah. Okay.
All right. Well, our special guest is
still asleep.
Well, it is a holiday, but we'll get them on in a future
eventually.
Day, but it was fun just to catch up with you.
And hear about your new job, which is really exciting. We'll be able to talk more about Kotlin stuff.
Yes. That'll be fun.
It will.